There's beauty in repetition. Life is full of repetition. Always the focus on new, new, new. But those who create the great new do it through repetition. Practice. Repetition with slight differences is iteration. Deliberate practice. Rapid evaluation of outcomes into decisions into outcomes into decisions. Since repetition is natural, computers have naturally always had repetition. In fact, they had repetition before they even had decisions. But together, repetition and decisions are a very powerful tool. You can make almost anything with just these two things. Decisions allow you to change the course of a program, to choose to do something or not do something based upon the state of the world. Repetition enables a program to react to cases where you don't know exactly how many times you need to do something. You've just taken a new gig at a designer fruit company. They have these new bananas that are really picking up. When an order comes in from a distributor, they ask us for a certain number of bananas. The bananas are picked in bunches, and it's not worth the time or effort to split up the bunches to give an exact amount. A picker will just keep picking bunches until they've hit at least the required amount, a little banana bonus. Thing is, it's difficult for them to keep track, so we want to design a program in which they can just type in how many bananas they need, and then start entering in how many bananas are in each bunch as they pick them. Once they hit the right amount, the program should tell them so they can stop picking. To start this program, we'll ask the user how many bananas we need to target, and then we can ask them how many bananas they just picked. We'll keep track of our picking progress by creating a total picked variable, and adding our pick count to that total picked variable. But we don't know how many times we need to ask the user what they picked, as it'll depend on how many bananas we need and how many are in each bunch. We could start wrapping each of these in if statements, only asking them for the next bunch if we haven't hit our target. This would keep reading in numbers, adding them to our total, and then skip over the rest of the questions once we hit our banana breakpoint. This can read up to 4 numbers, but what if we needed 5? What if we needed 10 or 20? We can see a pattern emerge here. We're repeating these 3 lines over and over again, as long as this condition here is true, as long as our sum is below the target. We can replace all of this repeating code by swapping our first if statement to a while loop. Now, instead of saying if we're below the target, do this once, it's saying as long as we're below our target, while total picked is less than target bananas, keep doing this. Now, when a picker starts picking, they enter the target amount in their order, in this case 18. Then they're asked for the first time how many bananas are in their bunch, and we add it to our total picked count. We migrate to our while loop and we check, are we less than our target? We picked 3 bananas out of 18. 3 is less than 18, so we enter a while loop and start asking the user to enter another number in. After we add our new pick count to total picked, we've hit the end of our while loop. When this happens, the program goes back up to the top of the loop and checks our condition again. 7 is less than 18, so back in the loop we go again. And we'll keep doing this again and again. Getting a number, adding to our total, and checking our condition. Until eventually we get to an iteration where we ask them one more time, and they enter a new number which brings our sum to our target. When we enter this 3, it brings our total pick to 19, which is more than our target of 18. So when we go back up to our condition, it'll now evaluate to false, since 19 isn't smaller than 18. This causes us not to enter the while loop anymore, and continue on with the rest of the program, which prints out our target reach message, telling our picker to stop, and our program ends. Over on the Apple side of the business, we get very large orders, and it's difficult to track the many crates we need for packing apples. We ship 3 sizes of crates, which we've creatively labeled large, medium, and small. Large crates can hold 30 apples, medium 12, and small 6. Since they're more expensive, we only want to ship entirely full large and medium-sized crates, and then use small crates for whatever leftovers are needed. We also need to write a reference number on each crate so we can track it. We want a program that helps us write out these reference numbers and determines how many crates we need. So if we had 42 apples to pack, we'd expect this program to tell us one large crate and one medium crate. But if we had 40 apples to pack, we'd expect the program to tell you to use a large crate of 30 and then 2 small crates, since we don't have enough to fill an entire medium crate. We'll start by asking the user how many apples are in this order. Then, we need to think about how to break down this problem. Sometimes it's useful to take a break from the keyboard and draw some ideas on paper. Break it down based off of how you'd solve the problem as a human first, before we get to code. This is my paper. Let's start with an example. How about 75 apples? If we had 75 apples to pack, what would we do? Well, we'd start putting in apples in large crates, filling them up until there's not enough apples to fill up another large crate. But why are we filling up large crates? What causes us to put them into the large crates instead of the other options? What's the condition that's triggering us? Well, we're putting them in the large crates as long as we still think we have at least 30 apples in our pile. Once our pile is below 30, we'd stop and look to other crates. So the logic we're applying to ourselves is, while the apples we have left is greater or equal to 30, then pack 30 apples into a large crate. After you've filled up all the large crates you can, you'd then look to the medium crates. We also want to fill up medium crates, so we'd follow this pattern. As long as we have 12 apples left, we'd pack 12 into medium crates. In our 75 apples example, after filling up 2 large crates, we'd have 15 left, enough to fill up one entire medium crate. Then we'd just put whatever we have left over into small crates as long as we still have apples. That's another way of saying, while apples left is greater than 0. Add apples to small crates. Now that we have a rough idea broken down, we can start converting our ideas from paper to code. We have this concept of apples left. How many apples are still left to pack? So we'll create a variable which represents this. To start, that variable should just contain all of the apples, because we haven't packed any yet. Okay, so we said we want to keep packing large crates as long as our apples left is still at least 30. So we can add that while loop, and that'll keep executing as long as there's 30 apples. For every loop we create, we need to do 2 things. First, we need to do a slice of work on one thing. Typically, you can think of each iteration of a loop as handling one thing, and doing something to that one thing. If you're putting away dishes, you're doing the same task over and over again, but each time you're handling a different dish. One dish per execution of the loop. The second thing we need to do is make sure our condition is getting updated appropriately, so that way we'll eventually exit the loop. If we ran this program right now, we'd just keep looping forever, so fast that the fans on your computer might turn on. The apples left variable is stuck at greater than 30. It never changes, so our condition is forever true. While you're putting away dishes, you look to see if there's any dishes left. Based on that, you'll decide if you need to keep going. If you ever get stuck like this in a loop, remember you can always stop a program with Control-C. Think Control-C for cancel. So let's handle our current item. We want to tell the user to pack one large crate, so I'll add a printf that prints L for large. For the reference number, we'll tell each employee what their starting reference number is for the day, and then the program should increase it from there. We'll use a reference number variable to track the current reference number. Inside our loop, we'll print the reference number for the crate, and then add 1 to the reference number so that the next crate will get a different unique number. Okay, we've handled the current item. Now we just need to make sure our condition is updating. If we just packed 30 apples into a large crate, we need to subtract 30 from the apples left variable. That way it reflects the current count of the apples that we still need to pack. And it also means that eventually this loop will end. Let's quickly test our program so far. It asks us for our starting apples, which will say 90, and we'll put 100 for our reference number. Then the program sets our two updating variables, the apples left variable, copying over the 90 from apple quantity, and the reference num from start reference num. Then onto our loop. We have more than 30 apples left, so we enter our loop. We'll print out a large crate and the reference number of 100. And the reference number gets increased by 1 to 101. And we subtract 30 from apples left. Back up to our condition. Apples left is less than before, but still greater than 30. So back in we go. Another crate, but this time with a new reference number. After this loop, we're down to 30, but that's still enough for one more crate, so we print again. This time, our subtraction will bring us down to 0 apples left. Our condition became false, so the while loop will end and also our program. As expected for 90 apples, we got 3 crates in our output. Now, let's handle the other crate sizes. Medium, we said, was pretty much the same as large. As long as we have 12 or more apples left, we can fill up a medium crate entirely. Small is a little different and serves as a catch-all. We'll keep crating until there's no apples left at all. That means we want a condition that repeats as long as apples left is greater than 0. What's also different is we need to figure out how many apples to put into the crate. If there's enough to fill up an entire small crate, we'll put in 6. Otherwise, we'll just pack whatever's left over in the last crate. So if there's only 3, we just want to put 3. With the number of apples figured out, we can print out our crate, the number of apples, and the reference number. And then instead of subtracting a fixed number of apples from our apples left variable, we'll remove the exact amount that we packed. Now our program can figure out all of the crates we need. Let's put in a bigger number and see what happens. 167 goes into our apples left variable, and it'll start packing large crates. 5 of them, actually. Until our apples left variable is brought all the way down to 17. 17 isn't greater or equal to 30, so we'll stop looping and head down to the next while loop. We'll now check if we can fill any medium crates. 17 is greater than 12, so we go in and print our medium crate. But we only have enough for one medium crate, so on the next condition check, we're already done with this loop. Lastly, our small crate loop. We'll enter as we still have 5 apples. Since there isn't 6 or more, our crate amount is set to the rest of the apples, 5, which is printed out, and then subtracted from apples left. That leaves us at 0 apples left. So when we check our loop's condition, there's no apples left, so we can stop looping, and our program ends. Our program is a lot more dynamic now and can react to different numbers, a different set of inputs, and we get very different output. For 71 apples, we'd fill up 2 large crates, completely skip over the medium crates entirely, and give us 2 small crates, one completely full, and one with leftovers. With that, you now have the basic mechanics of while loops. We're about to take this more advanced, but before we dig deeper, it's a good idea to start experimenting with while loops. Gary, the cow, has returned on codeaesthetic.io. He got himself stuck in a corn maze and needs your help. Gary has just enough signal to send and receive text, so he sent you a final pleading moo. You found the maze plans filed with the city, and you need to send him exact instructions on how to get out. Using while loops, you can send exactly the correct steps he needs for salvation. Just with what I've shown you so far, you should be able to complete the first 3 experiments where you help set him free. Back to our apple picking program, there's one last requirement we need to add to our program for it to be ship ready. We need to add an audit trail of how many apples are being packed in total and how many crates are being used. This will help us find if any apples are mysteriously going missing during the packing process. Don't want any atrocious Apple abductions. The goal is for a packer to launch this program once when they clock in, enter their employee number, and then keep entering in as many orders as they need throughout the day. Once they're done for the day, they enter in 0 to finish the program. A status summary is logged with the total number of apples they packed and what containers were used. For this change, we need to determine which parts of our program we want to repeat and which parts only happen once. The first obvious one is the employee number. That only happens once at the beginning of the program. We can simply add that new question to the top. The reference number question should also only be executed once at the beginning of the program. So I'll move that to be next in our intro questions. Next, we have our apple quantity question. We know that we want to repeat this question over and over again. So our first inclination might be that we want a while loop around this question and everything else. Then put a closing brace at the end. When you need to indent lots of stuff in a text editor, you can usually do that by selecting all of the text and hitting Tab. Doesn't look as cool though. What should go in our condition? Well, we said we want the employee to keep entering new orders and stop once they enter 0. So we want to say something like this, while apples quantity doesn't equal 0. But this won't work because our apples quantity isn't set to anything specific yet, since we first set it inside of our loop with our scanf. So we'll need to move our question back out front of our loop. This way, we'll ask them what they want to pack, and only if it's not 0 will we start packing the first crate. But remember our two things. All of the code within this loop, including these inner while loops, handles one order of apples and its crates. That's number 1. Number 2, we need to make sure our condition is updating. We need to make sure our apples quantity variable is being updated. Every time they finish with an order, we need to ask them again, what's the next order? It feels like this should happen before we process the order, but it's actually the last thing. We basically ask, and anything else? When we test our program now, it'll ask us for the employee number, the reference number, then keep letting us enter orders until we enter in 0. Then our outer while loop ends. Our loop works as we expect, although you might have noticed that our reference number is broken. Every time we enter a new order, it restarts counting from our starting reference number. We want it to continue to count across all orders. Once we dig into this, we'll figure out that we're resetting our reference number here. Every time we start another iteration of our loop, it's getting set back to the start. If we move this outside of our loop, we'll only set up our reference counter once, and it'll keep incrementing throughout the entire lifetime of the program. Now we just need to add our stats. We'll add variables to track the total number of apples and each container type. Then we'll add to the total apples whenever we start processing a new order at the top of our loop. And we'll tally up every iteration of our while loops for each container. And finally, print out a summary record at the end. Now when we run our program, it has all the features we want. The employee can keep processing orders, and when they're done for the day, they'll enter in 0. Then their stats are logged for the record. One last thing I want to point out before we get experimenting. When you declare a variable, you can only use it within that set of braces, called a block, and any deeper blocks within it. We call this the variable scope. If you try to access it from outside, C will complain that the variable doesn't exist. It's not something you have to think about often, but it can come up. An example in our code is our crate amount variable. It only exists inside the loop, and it ceases to exist when we're done with this particular iteration. But that's okay, it's reborn anew when we need it for the next. If for some reason we needed to access it outside of the loop, we need to declare it on the right level. Now that we have loops and if statements, we can make our code do almost anything, and things start to become more about how we figure out the logic of things rather than the mechanics. The last 3 experiments on codeaesthetic.io will push our logic skills further.